Our next presentation is entitled, "For the First Time We Can Add the Right Amount of Admixture for Each Individual Load." I'm pleased to introduce you to Nathan Tregger, who's the Director of Data Analytics for Verify, now part of Saint-Gobain, located in Andover, Massachusetts? You can tell I'm from Canada. Over the 12 years with the company, has worked on a variety of concrete admixture projects, as well as providing data insights through Verify. He's an active member of ACI committees 135, 212, 237. He's the chair of 238, and also an active member of 241, 304, and 552. I'm not sure how you get any work done at Saint-Gobain. All right. Well, come on up and tell us what we need to know, Nathan.
All right. Thank you, Kirk. And first of all, just my apologies for missing the previous presentation. So I was in the other room moderating that session. So, all right. So I'm going to start my slide off. So I gave a recent talk at Georgia Tech. That was a refresher for me to see how young students are. So my first one was on Julia Childs, and I didn't know how well it would land, but I have a much, let's just say, seasoned audience here that should be a little bit better. So in all of these admixture talks that we've had over the years, you see the tremendous amount of engineering that goes into these chemicals, right? There's a tremendous amount, has to deal with a ton of variability in your materials and everything. And so what got us thinking about this a little bit was that we were really heavy on chemistry. So if you're going to marinate your steak, for example, you really do have two ways of doing it. A marinade, which is a chemical way, breaks down, the proteins and all that. Don't quote me on that. Something like that. And then you have the Julia Childs way, right? Just smash that thing to pieces and break that up. And it was really interesting because I tried to find a recipe that had both, and I found one. In case you guys want to make it, it's over here. But that really applies to what we've done in the concrete industry as well. So here's I'm sure you guys have seen this slide quite often. On the left, it shows basically slump over time for different chemicals. Right? And so you might have, so PC1 is DR, which we call dose response. So it gives you early slump, but then you can see the orange line just starts to die right away. Not a lot of SR or slump retention. Then you kind of have a blue one, which is a little bit in the middle, and then you have this funky red one, which really has no DR up front, no dose response, but then the slump builds over time. And so all of the clever admixture people in the room, we know that this is our bread and butter, how to formulate these really, really carefully to get something like the green. Great slump up front, long slump life, and of course everything dies at some point. So polycarboxylates are a huge part of this. I think Larry talked about some of this maybe a little bit. But this is long history, and it's something that we're quite familiar with in our maturity as an industry. All right, I'm going to jump now to kind of the IoT or Internet of Things. I think most of us have seen this everywhere, almost kind of intrusively, right? We have sensors that go into refrigerators for ice cream that tell you when things need to get changed or if issues are happening. There are marketing RFID chips that are in whiskey bottles. And this, basically, you click on this and it saves your information. Be careful with all these things. Saves your information and then gets marketing information back. Probably one of the closest ones is the agricultural industry, right? Also a very kind of dirty industry, lots of heavy equipment, but they've done a real great job at censoring these things up. Basically, they have self-driving tractors out there. It's crazy. And the reason why a lot of this has happened is because these sensors have started to become so cheap, right? And this, by the way, this is one reason, right? Apple makes how many of these every year? Accelerometer in here, you have temperature sensors, so these have really started to come down in price. And people are not only using these to get information about their products and all that, but they're using that really to put it up to the cloud, and this makes the whole IoT loop. Put it up to the cloud, and you can really start to do some amazing analytics, analysis, all that kind of stuff. So what I'm going to talk about today is kind of this mechanical feedback system through IoT. So there are systems out there, and I'll talk about one today, that have instrumented the concrete trucks. All right, so you get, in case of this one here, we have pressure sensors that look at both when the drum is in charge or discharge, and we can also measure the drum rotation as well. You have temperature sensors on these things, and for this specific system, we also have the ability to add water and admixture in response to what those sensors tell you. And that's the real key thing that I'll talk about today. So this has been out here for a while. It's about 160 million cubic yards that we've put through the system. And for us in the US, we love to have different metrics. This is 400 Golden Gate bridges. We get data off these every 30 seconds from all the trucks out there. So we have way more than 1 billion data points on just the entire way that this is used from a producer's standpoint. So on the right here kind of just shows you an example, let's see if I can do this, of some of the data that you get off of this. So the sensors, specifically the hydraulic sensors, tied with the rotational sensor, basically like a rheometer, it gives you an indication of slump. So you can track this slump. This is coming off every 10 to 30 seconds. And so you can see this green dots here. This gray line is a target that's set by the producer. And so the system has, because of this feedback, it knows what the slump is and can automatically add water or admixture based on whatever the instructions are from the producer. So in this case, the instructions were get your slump up to an initial target with water, and then afterwards switch over to admix and manage the load. So as the slump dies, as it will, instead of relying on a super heavy slump retaining polymer, you can add basically maybe a less powerful one, but maybe more often. But because it's automatic, it makes everything a lot easier. All right, so the slump is maintained, the admix is added, it drops down here again, your admix comes up. Okay, so I'm just going to go quickly through the ready mix delivery cycle. Most of us are familiar with it in this room, but just for those who might not be. Basically, you have your concrete truck that's batched, and this is where you would put your chemicals in. Right? Traditionally, this is where you put your chemicals in. Obviously, the water goes in as well. And then also initial adjustments happen. So, and we'll talk about who does this. The truck goes to the job site, arrives at the job site. Sometimes it's allowed to have final adjustments, sometimes not, and then of course you need to get it out of the drum. So traditionally, you have a batch person that's in charge with this initial water. Or it's usually called the trim water. So they can actually, based on the recipe, they can actually hold out about a little bit of water. And actually you'll see a lot of people end up doing this. The truck gets batched, it goes to what's called the slump rack, and then the driver, in a lot of cases, has also the ability to make adjustments that they need to do. All right, and they usually do this while they're cleaning the truck. Gets to the job site, and then again, like we talked about, final adjustments. So just a quick diversion on this. There are a lot of challenges, all right, dealing with this. And so we kind of, I'm going to go backwards through this, but just to give you an idea of where we're going. This is number of loads, this is a histogram, number of loads, and on the bottom here is something we call initial slump versus target. So the system with the sensors on it, the first stable slump it gets after batching is called the initial slump. So everything's mixed in there, and then you have, and this gives a good indication, by the way, of your batching processes and all that kind of stuff. So this right here goes from -6 to 4 inches, right? And for those of you who don't know, the range on the slump test is, right, it's basically that entire range. So that's kind of what we're getting to, a large amount of variability. And you kind of, piece by piece, try to figure out what's going on here. One of the things is basically you can look at how the initial slump varies with the driver. All right, this is over time. This is 80 points. And you can see it's, the values bounce all over the place. That's one driver. Now, the batch person is responding to each one of these drivers individually. All right, and if they know, oh, this driver usually empties his drum all the time, I don't need to put a lot of water in there. But sometimes he knows that drivers, keep water in there, and so he trims back the water. But how can this one person have to deal with all the other drivers, remember all the behaviors, and the behaviors are constant? And so that's what this plot right here shows, is that these are all different drivers and their variability in how well they batch their concrete in that relationship with the batch person. So that's why we say it's kind of a team sport to make those decisions. That's very challenging to do, all right? So what the system does, and this is kind of the IoT on the bottom here, is that because we have all of this data, because we're allowed to make changes through the system, you just say, hey, batch low, batch an inch or two low, and just let the system take care of it. And that's kind of what we talk about through this whole stage. So the initial adjustments can be handled, any in-transit adjustments can be handled, final adjustments can be handled, and it's handled by the same machine, right? So you're kind of taking the human element out of that. All right, so what I'm going to do now is just make a very broad comparison. So I lumped a bunch of customers' data together. This isn't one customer or anything. Lumped them all together just to show you generally what we see across the industry and just some interesting things that come out of it. And a lot of it that comes out of this is just highlighting challenges that we have as ready-mix producers. And it's fantastic that we've gotten to this point over the 80, 90 years creating all these buildings with this variability. All right, so here we have 1 million loads. This is broken up into slumps at different points in the delivery. So we have when the truck first arrives at the job site, and then we also have at discharge. So we all know that at the site sometimes water, other fluids are added, so there's a change in that slump as you look. All right, and so this again is slump versus target. So on average, you can see that as an industry, we do pretty well, right? Average is 0.5 different from your target. Half an inch, right? You're not going to get any better than that. At discharge, it's starting to creep up a little bit, right? An inch above. But you can see the standard deviations are just very large, all right, for this kind of system. On the right here, we have the trim. So this is basically your trim water. And then the water adjustments that are made on the site, all right? You can see kind of these humps here. All right, those basically, if you notice, those are like at integers, right? Nobody's trimming 2.37 gallons of water. It's 2, 3, 4 kind of thing. But one thing you can notice, at least from this group of producers, is that the average amount of trim is around 2.5 gallons, right? They're holding back water. They're holding back water. Yet, you see on the left side, you're still able to make your slump. Right? So there's a lot of things that go into, and I'm not going to talk about them today, but we just talked about the driver at the slump rack. You have moisture meters that you have to take care of, gray water, so that's water left in the drum before you batch the next one. Just the fact of taking your design in the lab and moving that to the field, sometimes those don't always correlate, and of course our good friend material variability. So those are all the different things that affect your delivery of concrete, and so that starts to peel back the onion to show you, hey, this is one of the reasons that we can see this variability. Just to give an example of the material variability, what we did for, and I didn't put this amount of data points in there. I think this was several hundreds of thousands of data points. What we can do is calculate the slump loss over time, the slump loss rate, and then I'm plotting the slump loss rate versus just how long the concrete has been around. And so you can see that there's a lot of variability in this as well. So this is the slump loss is mostly due to your material variability, while your age of concrete at discharge is traffic, job site delays, and all that. So having to deal with this, right? This is why there is a variability in water. This is why there is variability in your slump at discharge. But once you kind of identify this, there are things that you can do to, to help. All right, so we talked about earlier on having this ADMIX-MANAGED comparison, right? So we're able to add the ADMIX in response automatically to the concrete slump. So when it drops essentially ½ inch below target, ADMIX is added and automatically gets to the right slump. And so you can see that cleans up the variability. tremendously, right? Cuts it in half. That's a huge, standard deviation's pretty hard to reduce. Cutting it in half is really good. But that should make pretty good sense. You have a sensor on there, closed loop feedback. You're able to do that. The other thing that we wanted to look at was just this concept of how long your load is within target. All right. So so typically when without a sensor, you'll batch a little bit high, and then you'll let the slump fall, and hopefully it gets to the right target when you get to the job site. So your slump is in target at the very end. All right. Or if you're unlucky, it kind of goes and drops down below. The other part here is, so if I calculate, for example, this load right here, it's about 50% is within target. Hopefully that makes sense. So we just looked at the last 3 months of data, 600, 700 loads, and looked at the average. So how long was your delivery within 1 inch of your target? Actually, half an inch of your target. And when you were manually managed, right, without the sensor system, you're running at about 60%. And that bumps up to 70 when using this system. But more importantly is probably the standard deviation, which is very drastic. The other part here is that for the manually managed, there are actually loads that never were in spec, right? 26% versus the 3. So you can kind of get an idea of how this really closes down the system. Sorry, Terry, how long do I have to? Oh, I should slow down then. We'll take more questions. That's what we'll do. All right. I think one question that I'm just going to answer right away is, when you add the admixture over time instead of all up front, how does that compare? Right? I think most of us know, depending on the system, but a lot of times we'll tell customers delay your admix, right? Especially your polycarboxylates. You'll get more efficiency after that. And what it turns out is that the longer you can delay that, the more efficiency you get in that to keep the same amount of slump. And so we did a quick study with one of our accounts. They're actually here today, where they did a comparison of 2 different delivery methods for the same project, same mix design, same time frame. And so what they did was they said, okay, we'll do things normal, however we did it before, and then what we'll do is that we'll take we'll use the ADMIX to manage the system. All right. So what they did instead, when we talked about the trim before, they said put all the water in and then just use the admixture whenever you need it. And also they pulled out the admix from the plant. So no admix in the plant, everything's on the truck, and then they'll manage that way. So that's what we call in transit, right, this blue. And then when the admix was added at the plant, it's this red. And the admix added at the plant, you change your slump the normal ways that you would typically do. So first of all, we can look up here. You can see the blue, which is this guy here. Too much coffee today. You can see the blue here versus the red. Oh, you can't see that either. You guys can see it. The skinny one versus the not so skinny one. Knock down your variability quite a bit. All right, this is again slump, your slump versus your target. This is for a good amount of loads here. And so with that, there's 2 things that happen is, again, you're adding all that water back. You're still meeting strengths, so strengths are all met. And then you're using the admixture when you need to. Instead of when you're putting the admixture up front, sometimes you need it all, sometimes you don't need it all. Whereas when you're just incrementally dosing it, you're just doing exactly as much as you need for that slump. Because your slump, you might need the slump for 45 minutes, you might need it for 75. You're just putting that slump, the admixture in when you need it. And so what you can do is you can compare, this is basically the amount of admixture used for each of these loads compared to your plant admixture. All right. And so and this is, it's, sorry about the wording, but it was for a paper, so we try to sound smart. This is admixture savings. So positive means you're using less. All right, so you can see on average, I don't know, 500 mils per cubic meter, or what is that, 10, 12 ounces a yard. Yeah, 12 ounces a yard of admix, right? For this particular case, this set of cements, materials, all that kind of stuff. And of course it's a range, but that speaks to just how well this works, okay? All right, and more information can be found. I think it's in it's in ACI. You can contact me if you're interested in that. All right, so just to sum up, you know, putting this chemistry and IoT, we don't, it's not one or the other, right? It's really a combination of the both. It's using both of them as you can. And I think we need that as an industry because of all the challenges that we have. All right, we just touched on a few of them here, but the industry in general, and we've been doing a great job because of the knowledge that people have and the knowledge that people are sharing to do this. Admixtures, of course, you know, can admixtures and the multitude of SCMs, right? All these things add to this, providing opportunities for these kind of systems to do. So having some visibility on the truck can really help. I think there, if you guys look around in a lot of the other committees that are going on at ACI, people are looking at embedded sensors, they're looking at other truck-mounted systems. A lot of this is coming out, and it's really nice to see that in a practical sense, a lot of it is improving ways people are making their concrete. The other thing too, you know, just touching on this, we talked a lot about the producer, but the contractor is also benefiting from this. You know, having a truck arrive on site with the right slump in a consistent fashion really helps them out so that they can plan a lot better. There's some other benefits as well. So just stealing something from Tom Green, and is he here? I saw him before. You guys will have to take a picture for him. But you know, he's said this a lot of times. So for the first time, you can really add the right amount of admixture for a particular load. Not for a mix design, not for a job. It's really about that individual load.